All right, so this one is sum of geometric sequences. So we're going to take a geometric sequence, remember they have a common ratio, and add them all up. And you can use a sigma notation in your calculator, or you can use these nice clean little formulas. And I will show you at the end where they come from, or how to form them. So the first one is if we were given a sub 1 and r only. And the second one is if you're given a sub n, a sub 1, and your r. And then you can use those to find it. So the first one, a sub 1 is 12. And r is 3, so we're going to use the first one. So s sub 10 is our first 10 terms, and then we plug in 12 for a sub 1, plug in 3, and again our n here is 10. So you're just plugging these in. N is 10 into our formula over 1 minus 3. And then we take that and we plug it in our calculator. So to do that, you want to use alpha y to create a fraction. You don't want to do this in parts, you want to do it all at once. So just like that, close the parenthesis, and then the bottom is just 1 minus 3, and hit enter. So we get 354288, 354,288. So that is the sum of the first 10. And remember, these are geometric, so this one has a ratio of 3, so it's tripling, it's becoming 12. And then 36, it's going to get massive, so you get a big number. You can also use your general term. Remember, a sub 10 n is equal to a sub 1 r to the n minus 1, and plug these in. So a sub n is equal to 12, and then 3 n minus 1. So we would have the sum from n equals 1 to 10 of 12. So if we plug that in our calculator, it would also work the same way. So math 0, and we're going from 1 to 10. Let's come back down here and put x goes from 1 to 10. And then it's 12, parenthesis 3, exponent x minus 1. And then we hit enter. You see, same exact answer. All right, let's try another one. And so in this one, we actually have to find everything. A sub 1 is 2. And again, to find the ratio, we just divide any of the two terms in sequence. So 18 divided by 6 would also be 3. 54 divided by 18 is also 3. And now we have everything. And if it wants the first 7, we know our n is 7. So s sub n equals a sub 1, 1 minus r to the n, all over 1 minus r. So we plug that in, s sub 7, a sub 1 is 2, 1 minus 3 to the 7th, 1 minus 3, and that's all we have to do is plug that in our calculator. If we're going to use the general term, then a sub n would be 2, and then 3 to the n minus 1. So this would be the sum from n equals 1 to 7 this time, 2, 3, n minus 1. So that's what we would also plug in our calculator. So let's plug in both. And here we go. So we would get, for that one, is 2186, or the general term, 2186. 2186. So this is so far given, not given, and then also really not given on the third one. So we're going to use what we did before to find this. So if you remember the third term, a sub 3 is equal to 36. So this would become a sub 1 r squared, because it's the second time you have to multiply the r when you get to the third. It's always one less. And then a sub 4 would be 108 a sub 1 r cubed. And so we have one equation is this, and the other equation is this. And if you remember, we just divide. So these two are equal. So we're going to divide both of these into this problem. So we divide by 36, and that is also equal to a1 r squared. Let me do a quick fix here. That's supposed to be r3. I was getting ahead of myself. All right, and then they cancel. And so we end up with our ratio equaling whatever that is. So 108 divided by 36 equals 3. And you could have also said, well, look, it's only a sub 3 and a sub 4. That's only one away from each other. So if I just divide them, just like I did up here, it gives me a ratio. So now if we take this 36 equals a sub 1 r squared, and we plug in our 3 squared, we now have an equation that we can use to find a sub 1, which is 4. So now we have a sub 1. We know our n equals 7. We can find everything we need. So a sub 1 is 4. 1 minus 3 to the 7 over 1 minus 3. We plug that in our calculator. Alpha y. And then 4 parenthesis 1 minus 3 to the power of 7 all over 1 minus 3. Yep. And we get 4372. And there you go. So that is all 3 types that you're going to run into when trying to find the sum of a geometric sequence. They're given, not given, and you have to find them, or they're 2 different distinct points. And this method will work either way. I know this was a nice quick one, but using this method, just like we did in the previous problems, will work very well. Oh, so where do these formulas come from? Here we go. So the first one's very easy to see how they're changed. So if I take this and I convert a sub n to its general term, we end up with this. See, the r and the r to the n minus 1 just become n, because 1 minus 1 is 0. We can then factor out an a sub 1. And so that's why those 2 formulas are the same. Okay, now if we look at s sub n is a sub 1 plus a sub 2 plus a sub 3 all the way to a sub n. So plugging in our general form, a sub 2 would be a sub 1 r, a sub 1 r squared, and then a sub 1 r to the n minus 1. Now here's the trick. If we take and multiply everything from s sub n by a negative r, we end up with this. And the reason we're doing this, you can now see things will cancel. So if we subtract them, in this case add them, we would get s sub n minus r s sub n. We would get a sub 1. And then this one would cancel this one, this would cancel this one, and then so on all the way to here, leaving us with just a sub 1 minus a sub 1 rn. Pretty cool little trick, right? All right, so now we could factor out a sub 1 and divide. And there is our formula. And there you have it. Thank you.